If you follow this tutorial, you will design this PCB and you will build this keyboard by yourself, even if you have never designed anything before. You will also learn how to design any custom keyboard with your own keys and your own layout, for example, like this one. And you will learn how to create this beautiful case. It is color 3D printed, which means you can customize it and use any picture you like. Also, what is very important, while working on this tutorial, you will learn all the essential knowledge to start designing any electronic product. Once you finish your keyboard, you can use it every day. For example, I used it to edit this tutorial and it's super useful. It is very easy to customize the shortcuts, create macros or change colors. You can do it directly in your web browser. This project is open source. All the files needed to build this keyboard can be downloaded from my GitHub. Links are in the description. There is also a link to the finished project, and in the description you will also find all the links to the following videos in this tutorial series. Check it out. Now, be ready. As we are designing and building the whole product, it will take you a couple of days to finish this tutorial, but it's totally worth it. This tutorial includes everything: drawing the schematic, doing PCB layout, and designing the case. You will also learn how to send everything to manufacturing, how to order all the components, and how to prepare and customize the software. And do you know what is super cool? To design this keyboard, you don't need anything, just your PC and an internet browser. There is no software installation and no previous experience with electronics or mechanical design is required. To build this keyboard, you will need some money, but it can be built for a price starting between $50 to $100. In this case, you only need to order PCBs and buy components for one keyboard, but you have to solder down everything by yourself and 3D print the case at home. Of course, if you don't want to, you don't need to build the boards by yourself. In the tutorial, you will learn how to order PCBs with components already soldered down. I will show you how to order color 3D printed case or buy customized keycaps. But be aware, in this case, the price can go up to several hundreds of dollars. However, the result looks amazing. And what about the software? For this keyboard, there is no extra work on software. Just copy and paste the files from the project. If you are building your own keyboard, in this tutorial, I will explain how to customize the code and build the software for your own keyboard. It's very simple. And that's everything for the introduction. Have fun. It is a really great feeling when you hold your finished keyboard and you know it was you who designed and built something that is useful and looks so cool. Go for it. In case you have any questions, feel free to ask them in the comments or on our Fedevel Discord. And when you design your own keyboard, don't forget to send me pictures to info@fedevel.com. Enjoy this tutorial and let's start. Search for Easy EDA. This is the website what we will use to design schematic and PCB. Go there. Then register and log in. It's completely free and we are going to use Pro Edition. Click here. I'm going to close this. File, new project. And I'm going to call our project Custom Keyboard. I will copy this, save. And I'm going to rename this. I will use custom keyboard again. And also I'm going to name our schematic. Again, custom keyboard. And PCB, it's just going to be PCB, so I will delete this. Okay. Inside of the schematic, there is already one page. I'm going to call it MCU. Here is going to be the microcontroller. And we need one more page. On this one, we will have everything else. So I'm going to call it Other. Okay. Save everything. You can double click on the pages. or you can use the tabs here. And I'm going to make few changes. So I'm going to change this. I would like to have there my, copyright and company and, all these things. You can use your own company name or your own name. You can put it here. And I'm going to change the size to A3 because this one is very small. Just confirm and do it again. Okay. And let's continue down here. So I'm going to change page size to A3. We don't need this one. We don't need this one. Version, this one is going to be version 1. And here I'm going to put my name, Robert Feranek. Okay, double check. Perfect. Do it also for the second page. So again, I'm going to change the size, A3. This is much bigger than A4. So we can fit everything. And company, Fedevo. Okay. Page size, A3. We don't need this. We don't need this. Version 1. And my name or your name. Okay, put here your name. So everyone knows you created this. Perfect. Okay, save. Now we are going to put here some titles. So on the first page I will put this one, custom keyboard page 1/2. You can change the color of the text, so I will use this brown. And I will use different font. Maybe this one, and make it a little bit bigger. Bold, and place it at the top of the page. This is useful because if you print your schematic, you immediately know what is this schematic about. Also, if you just generate PDF schematic, everyone knows what is in this schematic, okay? So it's useful to have the page name in your schematic. Okay, place it also on the second page. Okay, perfect. I will keep saving all the changes because it's, safer. Now, search for keyboard firmware, QMK firmware. This is the software what we will use in our keyboard. And based on this software, we are going to have a look what kind of hardware we need, what kind of chips we need to use, okay? We will use this RP2040. And our schematic is going to be based on this Raspberry Pi Pico board. So search for Pico datasheet. Okay. Now find the schematic. And this is going to help us to create our schematic. So first we need this RP2040 chip. So I'm going to close this. Okay, I'm going to copy or remember RP2040. And for components, we are going to use this LCSC website. Here we are going to find the microcontroller. And we are using this LCSC because then we can directly insert the components into our schematic. Here it is. Okay, copy this part number. And now when we go into our schematic, place device, find it here, and see, we can directly place this component into our schematic. This is super cool. It can save you a lot of time. But I'm going to make some changes because I like to adjust this symbol. So in project, in the project libraries, save as our microcontroller as our custom symbol. I'm going to add RF version 1, so I know it is my symbol. Okay, we would like to create also new footprint. Footprint is the physical interpretation of the component. And then go to personal libraries. Here is the symbol or the component what we have just created, and click on edit device. Okay, so now we can basically customize the symbol. I'm going to make few changes. Just make it a little bit wider. I'm going to make the changes because I like to place pins in specific position. For example, you will see, for example, all the powers at the top, all the inputs on the left, outputs on the right. So I'm going to move it a little bit like this. I like to have crystal at the bottom because it requires a little bit bigger circuit. These are some control pins. This is the flash where the firmware is stored. Oops. I'm going to place it like this. Okay. Be sure grid is 0.1. Okay, this is very important. All the pins need to be on the grid. And I'm going to place these differential pairs, USB signals, on the left side of our symbol. Okay, so these are all the signals on the left, and I'm going to make it a little bit nicer also here around the powers. This is what we are doing. This is exactly the same way what you would use even if you need to create your own custom components. So this is how you would do it. Notice when I draw it from bottom right, everything where the rectangle is touching will be selected. If you draw it from top left, only what is inside of the rectangle is selected. Very useful. Okay, move it, and also move this a little bit. Okay, now I'm happy with this symbol. We can save it. Go back to our schematic. We can delete this one. We don't need this one. And we are going to use the symbol what we have just created. So personal library, this is the component what we adjusted and placed it. Oops, looks like there is a problem. So if something like this happens, if you can't place symbol from library into schematic, just save it again. So I made change, so I can save it again, go back and try it again. Usually this doesn't happen, but sometimes it may happen, so I left it in the video in case it happens to you, so you know how to fix this problem. Okay, now we have our microcontroller, Raspberry Pi microcontroller in our schematic. I'm going to place it somewhere into middle. And now, we need to place their other components. So we are going to start with these decoupling capacitors, 100 nanofarad capacitor. I'm going to search for 100 nanofarad 0402. That's the size of the capacitor. And There are many, so we are going to use components from Samsung 0402, search for 100 nanofarad, and we would like to select the components which is in stock, for example like this one, copy the LCSC part number and simply place this component into our schematic. Okay, see, super simple. It's very simple to actually create schematic. You just need the reference schematic and then follow it. All the I/O VDD pins, they have 100 nanofarad capacitors. I'm just checking the schematic. Okay. And also this USB VDD has 100 nanofarad capacitor connected to 3.3 volt. Here is USB VDD, and here are all the I/O VDD. So each of them needs 100 nanofarad capacitor. Just copy and paste the previous 100 nanofarad capacitor, the one which we already have in schematic, and do it for every single pin. So we need how many capacitors? 7. Like this. Okay. This is how we make the connection. So we are going to draw connection between this pin and this capacitor and connect all the other capacitors. Connect all the pins. Okay. And connect also all these other capacitors. We need to connect this to power. Okay. Go back to schematic. It's connected to 3.3 volts. So select this symbol and just change the name to plus 3V3. Okay. And we also need to connect the second pin of the capacitor to ground. So place again this power net ground and just move it. I'm going to hide the name. Okay, I'm going to copy this and paste it on every capacitor which we have in schematic. Perfect. Save. Next, we are going to connect 100 nanofarad capacitor to 1.1 volt and to these DVD pins. Here is also 100 1.1 DVD, and here is 1.1, and it's connected to VREC Vout, and there is this 2 micro 2 capacitor. So here are the DVD, this is the VREC Vout. I'm going to copy 100 nanofarad. Paste it here. We need 2 of them because we have 2 DVD pins. We can connect it. Connect these 2 together and connect everything to the capacitors. Okay. We need to connect capacitors to ground. Just copy and paste the existing ground connections. We are going to name this net So when we will be doing PCB layout, we know it's plus 1.1 volt. And now we also need the second capacitor, 2.2 microfarad. So I'm going to find it. Between capacitors. Do you remember which manufacturer? Samsung. Okay. Apply. Select the one which is in stock. Okay, this one is good. We can copy the part number and we can find the capacitor in the libraries. Okay, and we can place it into our schematic. Okay, it's connected to VREC Vout. So I'm going to move it here and we are going to connect it. Connect also the ground. Perfect. Now, there is another micro 2 capacitor connected to 3.3 volt VREC in. So I'm going to copy the capacitor again and place it close to the VREC in pin. Okay, and we are going to connect it based on the reference schematic. We are going to connect it where? Do you remember? 3.3 volts. Okay, I'm going to copy this and paste it. Okay, here is another one connected to ADC AVDD. So I'm going to copy 2.2 microfarad, place it here, and we are going to connect the ADC AVDD. We are going to connect it to the capacitor. Okay. Now they have these two resistors here. We are not going to use this one because we don't need this reference voltage. We will just use this 200 ohm resistor. So I'm going to find it in LCSC. Again, 0402, that's the size of the resistor what we are going to use. Chip resistors and manufacturer, this one, okay, Uniroyal 200. And all the resistor what we will be using, we will use plus minus 1% tolerance. Find the ones which are in stock. Okay, this is exactly what we want. Click here, copy LCSC part number, find it in the libraries, and place it into our schematic. Okay, we are going to connect this, and here we need to place this 3.3 volt symbol, and I'm going to name this net because it's important. Net, when we will be doing layout, we would like to know its power, so I'm going to call it plus 3V3A, like analog. Okay, if you don't name the net, then it will have kind of weird random name. That's why we are placing the names there. Next, ground. We can connect the ground. Here is ground and here is ground. Okay, here are the 2 pins. So we can connect these 2 pins together and we can connect them to ground. I will copy the ground symbol, paste it. Okay. Next, these resistors, 27R. We need to find them first. Just change this to 27. Okay, we are going to use again Uni Royal 0402. +/- 1%, and we can use this. Okay, copy, and paste the 27, or place the 27 ohm resistor into our schematic. We are going to connect it to USB pins. I'm going to make this a little bit nicer. Copy and paste. We need 2 of them. And connect them to the microcontroller. Okay, this is important net, so we are going to name the net. I'm going to call it USB N, like negative, USB P, positive, and here they are. Okay, and they are connected here to this USB connector. I think this one is USB micro. We would like to use USB-C in our schematic because that's what is usually used now. So let's find something in connectors, USB connectors. We would like to find USB-C with 16 pins. That's the simple one. We don't need all the pins. And let's have a look what they have. This one says 3.1 USB, so let's have a look. Okay, this looks good. This looks really good. We can use it, copy, and place it into our schematic. We would like to flip it. Watch, we would like to have the pins on the right side. Okay. Place it maybe like somewhere here. So we have a lot of space for the components around the USB connector. And we can connect the USB pins. So I'm going to connect this negative pin to the negative pin of the microcontroller, and I'm going to connect the positive pin to the positive pin of the microcontroller. Now we need to connect this second positive pin and also second negative pin close to the connector. Okay, double check, negative, 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 positive, 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 positive. Very important, don't make mistake. What else we can connect easily? Ground pins. Okay, so I'm going to connect these. maybe like this. This one, copy the ground symbol, paste it here. These we can also connect to ground. These are the metal shield pins. I will just copy this, paste it. Okay, make it nicer. And V-bus, this is plus 5 volts coming from the USB. I'm going to connect them together. And this is going to be the plus 5 volts from USB. Don't forget to rename the net. Okay. Save. Now we are going to place protection on these USB signals, ESD protection. So I'm going to find something here, ESD protection 0402, and we will use this manufacturer. Let's double check. What is this component about? Is it what we need? Application USB 2, USB 3, okay. So we can use this one. I'm going to just double check what are the parameters. It's for 5 volts. 2. So we can use this one also on the plus 5 volt power. We can use it on the USB signals and also on the power as a protection, ESD protection. So I'm going to place it into our schematic. We need 2 of these on the USB signals. Press spacebar to rotate, okay. Copy and paste. And also we need 2 of them on the power. So I'm going to place one here and one more here. Okay. We can connect everything. So connect this one to negative, this one to positive, and these two connect here. We have 2 because there are 2 pins on the connector, and we would like to place this ESD protection close to each of the pins. Okay, connect everything to ground. And we also need capacitors close to this power. So I'm going to find 1 microfarad. Again, we will use Samsung 0402, 1 microfarad. Mm, 10 volts, 16 volts, 25 volts. We will use this one. Okay. I'm going to copy. And place the symbol into our schematic. Okay. Again, we would like to use two because there are two pins. We would like to place these two capacitors close to every pin on the USB connector. Connect them to ground. Make it nicer. Name the nets because they are important nets. So I'm going to call this one connector USB N. And this one is going to be connector USB P. Okay, again double check N, N, P, P. Don't make mistake. Next, what about the other pins, CC pins? How we are going to connect them? Search for USB-C CC pin table, and find this article. It is very useful article. Read it, okay? And this is what we are connecting, and this is what we need: RD resistor, and usually it is 5.1 kilo ohm. So we need to find this resistor and we need to place it into our schematic. So 5.1 kilo of 402 resistor. Find where are the resistors here. Okay, Uniroyal 5.1, 1%, apply. This looks okay. Copy. Paste. And connect it. We need two of them. Each of them is connected to CC pin. And they are also connected to ground. Okay. These two pins, they are not connected. So I'm going to place this no connect symbol on these pins. Next, we are going to connect this plus 5 to 3.3 volt, and we need a component between these two powers. Do you know what kind of component? We need a voltage regulator. So find voltage regulators, and I'm going to use Texas Instruments because it's a very good manufacturer. We are going to use this SOT223 footprint, very standard footprint for this kind of boards, and we would like to have output 3.3 volts. Okay, 1 amp. Apply. Let's have a look. What they have? This one is the one what I would like to use. They don't have it in stock, but it's okay, don't worry. I'm going to copy this. Very often they will have it in stock when we will be building the board, so it's fine. I'm going to place it into schematic. Again, press spacebar to rotate, and we need to connect it. I'm going to open datasheet because we would like to see some kind of reference schematic. Okay, this is what we need, and this is how we connect it. You see there are two capacitors. I'm going to double check what it says here. Okay, we need at least one capacitor here. And what we can do, we can use one of them what we already have in schematic, this 1 microfarad capacitor. So I'm going to copy it. I'm going to place it close to the input pin. Like this. And we can connect it. To 5 volts from USB. Okay, these two pins, they are ground, so that's easy to connect. Now the output, let's have a look. Output capacitor is critical, so ESR is important, and minimum capacitance at least 33 microfarads. So I'm going to search for 33 microfarads. There is not the capacitor what we normally use. So I'm going to search again. I'm going to select the Samsung. And let's have a look. We need a little bit bigger footprint. Let's have a look what is the biggest one. Close to 33, 47. Okay, we will use this one. We had to use bigger footprint because this bigger capacitance is usually only in bigger footprint. Okay, this is what we can use. And we have to double check also the ESR because it's very important. ESR limits. Okay, there is this picture. Stable region. So ESR of the capacitor needs to be in the region. I'm going to have a look at this ESR of this capacitor. Here are the graphs. It's approximately okay. Have a look. That's approximately the region what we need. So we can just use it. Copy and paste this. And we need to connect it. You can see the output is connected to 3.3 volts. This is the output. So connect it here, and also we need to connect the ground and make it nicer. Okay. I'm going to make also the schematic nicer, so I'm going to copy this and I'm going to put names here because we would like to explain everyone who is checking your schematic, who is looking at your schematic, what are these components for. So this one is used to go from 5 volts to 3.3 volts. This one is the microcontroller, and here is the USB connector. Okay. Next, connect the rest of the pins. So let's have a look. So we have this, we have this. We use something a little bit more simple. These are the headers, we don't need them. This is what is important. Crystal, 12 megahertz crystal. It's a very important component, so I'm going to have a look what they recommend to use and how they recommend to connect it. So in this RP2040 datasheet, they explain what kind of oscillator we would like to use, and they recommend this one, ABM8272T3 is this one. So I'm going to copy the name and we are going to find it. Again, they don't have it, but it's fine. We would like to use it, so click here. I'm going to copy this and I'm going to place it into our schematic. Don't forget, as I said, crystal is very, very important. That's why I would like to use exactly same what they have, what they recommend in their datasheet. Place it close to these pins. These are the pins which need to be connected to crystal. And let's double check the schematic, reference schematic. We also need 1K resistor. So I'm going to close this. And I'm going to search for 1K resistor, 0402. If this crystal circuit is not designed or selected, or if the components are not the right, then it may not oscillate and then your board will not work. So that's why I'm going to use exactly what they recommend, what they use. I'm going to copy this. And place it. Okay. What else we need? 15 picofarad capacitors. If you use different crystal, you also may need to calculate the value of these capacitors. Okay, but because we are using exactly same crystal, we are going to use 15 picofarad capacitors. This looks good. We can use it. Okay. Having all these symbols or components in the library already, it's very useful. If there are no libraries, you would have to create all these symbols by yourself. It saves a lot of time. And there is this resistor which is not fitted. So basically it's not very important what kind of value we will use, but usually it's like very high value. So I'm going to search for 1 mega ohm resistor. Even if it's not fitted, I would like to have some kind of resistor at least in the schematic. So I'm going to use this 1 mega ohm. We will place it into schematic, but we will mark it as not fitted. This is a good one, okay? So just use it. Place. Spacebar to rotate and place it. As I said, it's not fitted, so here we are going to change this to no. And also what I usually do, I place this text on top of the symbol NF and F, not fitted. Okay, so it's like very visible in the schematic that this component is not fitted. Okay, let's have a look how it is connected. So this one is connected here, pin 20. This one is connected here, pin 21. Remember, okay? Remember how it is connected. So this one is connected directly to the capacitor and to pin 1 of the crystal. And this one is connected to 1K resistor and pin 3 of the crystal. It is also connected to this not fitted resistor, and these capacitors are connected to ground. Copy, paste. These two are also connected to ground. Don't forget, we need to draw the connection and connect it to ground. Okay, perfect. I like it. Next, flash, and they use this 16 megabit. I'm going to find more information about flash here in this data sheet, and here they actually use bigger one, 128 megabit. So I'm going to copy name of this bigger flash, and I'm going to find it. Okay, we can use this one. Copy. Paste the flash into our schematic. So this is basically where the software or firmware will be stored. That's why I use the bigger one, because then you are not limited with the code, size of the code. How it is connected. We don't need to use this 2 micro tool, but we still need to use 100 nanofarad. So I'm going to copy this. This is called decoupling capacitor. If you would like to learn more why we need these decoupling capacitors, I created a number of videos, YouTube free videos about why they are useful. Or what you can do, you can also have a look on our online courses. At fedevel.com we have online courses. Again, they will help you to understand how to draw schematic, how to do PCB layout, why we are doing some of these connections, and why we place some of these components into schematic. Let's connect the rest of these pins. They are connected here. So first I'm going to make the connection on the microcontroller here. I'm just going to draw short line. We don't need to connect it directly to the chip. We don't need to draw the connection directly to the chip. The connection will be made automatically based on these net names. So if this net name is exactly the same here on the microcontroller as on the flash memory, then these nets will be connected together. Right now all these are connected together, but that's not what we want. We are going to change the names. So this one is going to be SD0. This one is going to be SD1, SD2, SD3, and clock. Okay, and I'm going to copy these net names. First I will save everything so we don't lose our work. I'm going to copy this and we are going to place them here. So basically this way we will make the connection between the microcontroller and the flash. So CS pin 1 SS net, this one, DO2 SD1, pin number 3 IO2, IO23 SD2. Be sure you connect this correctly. 5 is the input and it's this SD0. Then this one is going to be clock, I guess. Yeah, it's clock. And IO37, that's SD3. Okay. Now we still need to draw these connections. Okay. Now we have connected flash to microcontroller, and also we would like to connect this ground pin to ground. So I'm going to do that. Copy, paste, and draw the connection. Okay. I'm going to name this and I'm going to call it, you can guess, flash. Okay. See, if we don't place this name here, then people may need to search for this component on the internet, but this way they immediately know, oh, this is the flash memory. Next, this is connected to this boot select button. So we are going to find a button, switches, tactile switches, that's how it is called, okay? And I'm going to use this one and very small one, 1.5. They don't really have many. Okay, let's have a look. This looks good. We can use this one. I like it. Okay. Here it is. Place it somewhere down here where is the empty space, and you can flip it through the buttons, or you can use also spacebar to rotate. And we need to connect it to 1K resistor and then to the SS pin. So we already have 1K resistor. I'm going to copy it and paste it here. Connect it. these two are connected together, so I will connect them like this. They are connected inside of the switch. And I'm going to copy this net name and place it here because this switch is connected there. Okay. The second part of the switch is connected to ground. That's easy. And there is one more resistor, I think. Let's have a look. This one. Again, it's not fitted. So we just put there something, 100K. Again, it's not very important what kind of value we are going to put there because it's not fitted, but I don't want to put there a resistor with no value. So I use this one, the big one, and I will place it into our schematic. Okay, and they place it here on this side close to the SS pin, but this is not the most optimum way how to place this kind of resistor. So later we will change it. I will then show you how to update schematic when we will be doing PCB. I'm going to this is not fitted, so I'm going to mark it as not fitted, and also I will use this NF text on the top of the resistor. Okay, as I said, later we will make small adjustments to this circuit, you will see, and I will explain why. So I'm going to name this, it's called boot cell, so I'm going to use something nicer, boot selection, boot select button, okay, like this. Okay, because we have space for this nice text. I place it like this. Is it same? Okay. Save everything. And because we already have this button, there is one more button, reset. That's what we would like to use. We would like to connect one more button to reset signal. And they call it run pin. When it is low, reset then. Okay, so this is what we are going to do. We are going to connect button to this run pin. I'm going to copy it, and it will be used like reset button. And now, how to connect this reset button, do you know? We can search for reset circuit. There are many reset circuits, and this is the simplest one. So this is something what we are going to create. Maybe we will make it a little bit more complicated. We will add a resistor there. But we need 100 nanofarad capacitor, so I'm going to copy this one, for example. And I'm going to paste it here. And we also need 10 kilo ohm resistor. So I'm going to find it. I'm going to reset this and just find 10K. Okay, we can use this one. And very quickly we can build this reset circuit around the reset button. Okay, I'm going to make it more complicated. I'm going to use this 27 resistor and I'm going to place it here. We need to connect this 10K resistor to the power. This I'm going to connect to reset button. And here I'm going to connect the rest. Capacitor, resistor, ground, copy, paste, paste also here. Make it nicer. And do you remember where we need to connect this? Run pin. So where is the run pin? Here it is. I'm going to name this net reset N. Okay, copy and paste it down here. This circuit would work perfectly fine, but there is a better way how to do this. Because these two resistors, they are voltage divider between ground and power. It means here there will be never complete zero, okay? No zero in that point. So ideally, we would like to connect here this resistor. So later, we will move this resistor, we will move it to this point. I will show you later how to do it when we will be doing PCB layout, because we would like to learn how to update schematic after we start doing PCB layout. So for now, just leave it as it is, but don't forget, okay? We will improve this circuit a little bit later. Okay, I'm going to call it reset button and make it nice. What else is missing to our schematic? We have this, we have this. This is not important for us. We have this. Oh, we don't have this debug header. Okay, we can add a header into our schematic. We just need any header basically. So pin headers, a single row, 3 pin, 2.54, that's default pitch for headers. In stock, apply, and yeah, we can use this one. It looks like a standard header. Copy and use it. We are not going to fit it anyway, because we can do all the firmware update through USB, but this is just in case you would like to maybe do some kind of custom firmware development on this board. Maybe then you will use it, but normally it's not going to be fitted. So I'm going to connect it to ground, middle is in ground. And clock and SWDIO. So I'm going to name the nets. This one clock, and this one I/O. Double check. Okay, and they are connected to pin 24 and pin 25. I'm going to copy these net names. Okay, and I can connect it. Pin 24, pin 25. Be sure you connect them correctly, okay? Clock and I/O. (25, 24, 25, 24). Okay. I'm going to name this. Let's call it debug. Okay, and as I said, we are not going to fit it, so I'm going to select it, change to no, and also copy the NF text and place it here. Okay, and only one more thing is missing, this LED. So I'm going to search for LED. I can close all these. We can find any LED 0805, a little bit bigger than standard components what we use. Uh, 0805. Yellow. In stock. Apply. I use yellow because this is a user LED. And we can use this one. Okay. Double check. It's 20 milliamp LED. So that's standard. I'm going to copy. Okay, place it into our schematic. And for LED, we also need, do you know what we need? We need resistor. They use 470, but maybe we don't want to use another component. It will be cheaper if we use something what we already have in schematic. So I will use this 1K resistor. Very often these LEDs, they are also very, very bright even when 1K resistor is used. So I'm not worried. I think 1K, it will be good enough. In case you need, you can change the value of the resistor later when you use specific LED, okay? Don't forget, it has to be placed this way. Otherwise, it will not work. We are going to connect it to this GPIO 25, pin 37. So I'm going to find it. It's here. We can connect this. And then when you will be doing any firmware development or when you will be using keyboard application, you can control this LED to show something, I don't know, caps lock was pressed or something. Okay, I'm going to place it here. I'm going to call it user LED, so everyone knows this is user LED. And we are almost finished with this microcontroller page. There is one more thing what I would like to add. I would like to add also power LED. So I'm going to use very similar LED. Just instead of yellow, we would like to use green. Okay, they have something like this. So I'm going to copy it and we can use it. It's very useful to have power LED on board because you will immediately know that the board is powered and also that the power supply is working correctly. Okay, again, be sure you place it in the proper direction. The arrows, they need to face down to ground. Okay, like this. And connect the other side directly to power to 3.3 volts. Okay, because we would like to know the regulator is working fine. And place there also the text, so we don't forget this is power LED. Perfect. Save. Well done. You just designed your own schematic for a Raspberry Pi RP2040 microcontroller, which is going to be the brain of our board. In the next step, we are going to add the keyboard-specific circuits and components. For example, do you know what we are still missing? The switches, encoders, and most important, LEDs. So let's do it. The link to the next part of this tutorial is in the description under this video. And don't forget, if you would like to learn more about electronics, check out our online courses about schematic design, PCB layout, EMC, measurement. We have courses about KeyCap, Altium Designer, and more. Go to federal.com and have a look. Thank you very much and see you in the next video. Bye!